Hi, welcome. In this video, we will solve problem cycle in directed graph asked by many companies like Amazon, Microsoft, Facebook, and Google. Now let's solve one more problem on graphs. So that is the detection of cycle in a directed graph. So I hope you are clear with the directed graph that when we have directed edges is known as a directed graph. So given a directed graph with V vertices, basically V is this is the number of nodes that is I have represented with n. Take it V that are from 0 to v minus 1. So 0, 1, 2, 3, that is n equals to 4. Here 0 to 1 to 6, that is going till 5. And E is the edges. Okay, check whether it contains a cycle or not. The graph is represented as an adjacency list. So adjacency list is also given in the problem statement. And I hope you know what is adjacency list. Basically, if I say in my adjacency list at suppose 2, right, at an index of 2. So at an index of 2 I will get 3 because from 2 I can reach to 3, right? So this is the meaning of adjacency list, and they have also explained it that contains a list of vertices that are directly reachable from a vertex I, right? So from this index you can reach to 3. That's why it is written over here, right? Basically, if I say about 3, like for this one, right, if I am saying of an index of 3, right, I will put from 3 I can move to 4, so this will be answer, right? If I say from 1 I can move to 3, right, and from 1 I can move to 2, right? So in index of 1 I can move to 3, I can reach to 3 as well as I can reach to 2, right? So this is how basically this is what adjacency list is. Okay, now specifically adjacency I and j represents the edge from a vertex I to j, right? So I comma j represents the from I to j, the edge of it. Okay, so now we are clear with the problem statement. What we need to do, we just need to detect the cycle. Okay, again this problem, the same problem you can do by DFS as well as by BFS. Okay, we'll do it by DFS with the recursion technique. So let's see how we can solve this problem. Okay, and you can figure out that here there is a cycle, here this is a cycle. Okay, basically cycle is when you visit a node, okay, with the same path, okay, twice. So, okay, so suppose basically cycle, if I say what is a cycle, that is you are visiting a node, visiting a node. So when we visiting a node twice, okay, twice in the same path, the same path is known as cycle. So let's see basically what is the meaning of this line visiting a node twice. So see, you started from here, you visit this node, then right by adjacency list you will visit this one, then you will visit this node, and then again the same node twice by the same path, right? Exactly same path. Okay, suppose here you visited this node, then you will visit this node, and then you will visit this node, then this node, then this node, then you are visiting this node again, right, twice in the same path, right? That's why we are saying this is a cycle. Now let me tell you, is this is an example of a cycle that you have 0, then 1, then suppose 2, and then suppose 3. Okay, and then we have this. So see, right, you visit this node, then you visited 1, then you visited 2, then you visited 3, and that's end of it. Okay, that's end of it. From 3 there is no adjacency list, right? There is no any directed node. Okay, you will stop at 3. Okay, now there is also one path from 1 that is can reach to 3, so that's a different path, right? I will say this is path 2 and this is path 1. Okay, so that is on the different path. Okay, so when the things are on different path, we don't know call it as a cycle. So this is not a cycle. This is not a cycle. Okay. Now let's see how we will solve this problem. Okay. So let me quickly draw the same diagram here, or this one diagram. Let's quickly draw it. So now let's see how we will solve this thing. Okay. So basically, if you are using DFS, okay, you start DFS from here. Okay. Any node you can take it. You start DFS from here. Okay. And then you will visit this node because of adjacency list, right? Adjacent node. Then you maybe suppose you will visit this one, then you will return back. Okay. Then you will visit this one. Then you will visit this one. Then you will visit this one. And then you will visit this one. Then I will call that this is a cycle. Okay. Then I will call this is a cycle. So what I will do, I will basically use visited array. Okay. In visited, I will mark all these nodes as false. So 0, 1, 2, 3, 4, 5. I will mark all these as false. This is also false. This is also false. This is also false. All false. And when I am visiting it, I will mark this as true, right? So basically what I will do, I will visit 0. So I will mark this as true. Then from 0, I will visit 1. So I will mark this as true. Similarly, when I will visit this 2, I will mark this as true, right? I will return it back. Then what I will do, I will mark this 3 as true. Then I will move to 4. I will mark this as true. Sorry. And then I will visit 5 and I will mark this as true. And then I will visit 3 and I will check that this is already visited, right? That means I am visiting the same node. That's a cycle. Okay. That's a cycle. But here is one problem. What is the problem? Okay. See, when the cycle is not present here. So let me quickly draw the same diagram. Okay. And let me remove this one. Let me remove this as a node here and let me put it like this. So tell me first of all, is this is a cycle? This is not a cycle, right? Why? Let me tell you. So this is our 2. So basically you are visiting this node 0, then 1, then 2, then you are visiting 3, and 3 you can reach to 5, and from here you can reach to 4, then 5. Okay. You are visiting 5 twice, right? If I say from 3 I am visiting 5, and from 3, 4, 5 I am visiting 5. But the path is different, right? This is first path, this is second path. Okay, the path is different. So if I am using the same technique, by visited array, right? I will mark this all true and maybe I will visit it again. And if I am visiting again, I will say that this is a cycle, but it is not a cycle. This is not a cycle, right? This is not a cycle. And if I'm using the same thing, right? What I will do, I will visit 0, I will make it true. 1, visit, make it 2, 2, visit, make it 2. I will return from it, right? Then I will visit 3, make it true. Then I will visit 4, I will make it true. And I will visit 5, I will make it true. And from 5, that's the last point, I will come back and I will visit this 5 again from a different path. Okay. And then I will say, oh, 5 is also present. Then this is a side. So what I need to do, I need to create one more array. Okay. Okay. Or you can solve by simple array, that is also possible, but I basically use true and false. That's why I'm creating one more array path. And what I will do, when I will visit, okay, and let me remove this stuff. When I will visit, okay, let me create this path as well, this visited array as well. Let me put the indexes 0, 1, 2, 3, 4 and 5. So when I will visit 0, I will make visited true and path visited true. Okay. When I will visit 1, I will make it true and I will make path visited true. When I will visit 2, I will make it true. I will make it path visited. I will come back, right? When I will come back, when I will return, then I will say that this path is done. What I will do, I will again make it to false. Okay. That one, that is the only path. I will again make it false. Okay. Now I am come back to 1. What I will do, I have another chance to go to 3. So I will move to 3 and I will say this is visited true and this is also visited true. Okay. Now from 3, I have a chance to go to 4. I will say yes, I will visit 4. So this is done. right? This is done. I will make it true. From 4, I can move to 5. So I will make this is as true visited, and I will say path is also one visited. Now what I will do from here, because I reached to this point, from here there is no further any node. So what I will do, I will return from it. So once I will return from it, what I will do, I will make this true to false. Okay. Once I will return from 4 to again 3, what I will do, I will make this 4 to false. Okay. Now I am at 3, right? I have explored one path. But the second path is not explored. The second path is not explored this path, right? So I will explore this path. Like, remember, like this is your 3 node and you have 2 points, right? Either you can move to 5 or you can move to 4, then you can move to 5. So either you can take this path or you can take this complete path. Okay. So now what I will do, I will visit 3 to 5. So when I will visit 3 to 5, okay, when I will visit 3 to 5, you can see here I will check, oh, this is already visited. This 5 is already visited. But this is a different path because I am getting false. That means this is a different path. Okay, so I am getting false. So I won't say that this is a cycle. I won't declare this is a cycle. Okay, and this will not be a cycle. Now let's do apply the same logic here. Okay, apply the same logic, exactly same here. So I will simply remove all this stuff. Okay, and I will say I will visit 0. I will make this true. I will make this path as also true. I will visit 1. I will make this true, and I will make this true as well. I will visit 2. I will make this true, and I will make this true as well. Right? When I will come back, I will make this 2 to false. So I will make this 2 to again false. So remember, initially it was set to false. Okay. So when I will visit 1, 2, 3, I will say this is I have visited, mark this as true, mark this as true. When I will visit 4, right, I will mark this as true, mark this as true. From 4 to 5, when I will visit 5, I will mark this as true, I will mark. From 5, I will again visit 3 and I will check, okay, this is visited. Is path is also visited? Yes, that means they are in the same path. They are in the same path. And remember, now the point is visiting a node twice in the same path is known as cycle, right? So here I am visiting a node 3 twice basically in the same path. And what I will do, I will return that is true, that is a cycle. Okay, clear? Basically, this is how we are going to solve, and I hope you are clear with this, how we are doing visited and path visited. Okay, now what we can do, we can simply jump to our pseudo code. So let's quickly understand how our pseudo code will works, and then we will discuss the code implementation part. So let's check the pseudo code. So here, suppose I have this as a function is cycle. Okay, I will be provided with the v as vertices, that is you can say n, and I have provided with the adjacency list. Okay, now what I will do, as I have mentioned, I will create the 2 arrays. Okay, that is visited array. Basically I will create a array method with of size v, and I will fill it with false. So you can say dot false. Okay, then I will create one path visit, again same new array with the size of v, and I will fill it with false, exactly same. Now what I will do, I will simply run a loop that will start from 0 to v. Okay, I will take all the vertices and simple my function. If I have not visited, okay, if I have not visited of I, what I will do, I will call my dfs function, right? So you can put here this here, I can call dfs function. So my dfs function will be here. Okay, I will call dfs with my visit passing, with my path passing, with my adjacency list passing. Okay, and I can put one if condition here as well. Okay, that if this is returning me true, I will return true. Okay, because we need to return true. And suppose if I am not able to return from here, I will simply return it's done. So this whole code is done, and that will be my under cycle code. Sorry, this will become under my cycle code. Okay, now we just need to talk about how we are going to plan DFS, right? So if I simply cite, and now what I will do, I will create my DFS function. DFS, what are the things we have in DFS? So we have the node, okay, we have visited as my list, path visit, my adjacency list. Okay, now what I will do, when I am visiting node, I will make it true. So I will say when I am visiting a node, let's make this as true. When I am visiting any path also, I will make this node is equals to true. Then, right, what I will do, I will simply iterate through the neighbor. So I will say for neighbor of my adjacency list of node, okay, I will traverse in this neighbor, right? If now if is not visited, if any, again same condition, if I have not visited any neighbor, I will visit it. So I will say if I have not visited any neighbor, I will visit it. Okay, how I will visit it? Again same condition, I will visit it with if DFS. Tell you why I am using it. If DFS is visit path and adjacent, right, I will call this one, and this will return true. If this is returning true, that means that's a cycle. Okay, so what I will do, will return true if this condition is true, right? Else if suppose you have already visited, so I will say, right, is the path is also visited, if path of the neighbor is also true. Okay, so else if will be, first of all, remember, I am visiting this if condition with DFS of here. This will return me, right, if I am visited or not, right? So this will be return me true. Okay. After this, right, suppose I am talking about this condition, right? I will come from here. Okay, this is done. I will come from here. If I have basically if I have visited the area, right, that is already visited. So I will check the path of neighbor. I will check the path of my neighbor, right? If this is also true, that means that is in the same path. So I will simply return true here, right? I will simply return true. Okay. Else what we will do? We will do nothing, right? That is the end of the for loop. After end of the for loop, I need to do two conditions. That what I will do when I will return, right? When I will return, I will make path node equals to false, and I will return false. That means the for loop is done and I am not able to find any D. So basically this DFS will return. See, why in DFS I am writing if condition? Why in DFS I am writing if condition? Because this DFS will return true or false. When it will return true, if suppose you have visited the same path, visited, if you have visited it and path is also visited, then I am returning. When I am returning false, okay, if suppose during the for loop also I have not visited any of the thing, then I am returning false. So if I am getting false, I will return false, right? So if I am getting false, it will check for the other, and then it will basically, if it is true, so then it will return true, otherwise it will return false. Okay, so this is how it will work. Okay, I hope you are clear with it. Now what will the time complexity? Again we are using DFS here, and we are going till n of n nodes, where it's the n node, that is v vertices. Okay, v nodes. So basically the time complexity will be v plus e. Okay, and that is also ye, because it is directed edges, right? And which is can equals to big of v only, because suppose if you have only all nodes are single nodes, right? All nodes are single node and you need to find the cycle. Okay, in that case, you will, in the time complexity will be around big of v. And if I talk about the space complexity, so space can maximum to the number of nodes, right? So it will be big O of v. Okay, because the space complexity can go maximum to the number of nodes here. Suppose, like, suppose you do this function, right? Okay, when this will come on the recursion stack, again, this is of auxiliary recursion stack space. So we will take the recursion stack space. So this will be one function call, right? Then second function call, okay, then third, then fourth, then fifth, right? So it go up to big of V, right? That's why the space complexity is big of V, auxiliary recursion stack, and we are using these two spaces, visited node and path visited node. That is also big of V plus big of V, right? This is for visited and this is for one path visited. Okay. Again, that's constitute the overall space complexity as big of V only, right? And here we have big of V plus E. Okay. If you I have discussed this also earlier, why big of V plus E. Suppose, first of all, because we are visiting each node, right? We are going till V, so we are visiting each node, right? I is equals to 0, we are going till V, and also we are visiting one particular node with its edges, right? So if we have 1, 2, 3 edges, so I'm visiting this also, right? I'm visiting all its edges as well, right? So that is why, that is also one time, because we have visited node equals to true. Okay, I won't visit it again. So that's why V plus E, it will be a big of E. So I hope you are clear with the time and space complexity. Okay, and the code is completely clear. Okay, now in the next video, we will move to the code implementation part. So see you in the next video.